Hi, in this video, we will talk about how to divide rational expressions. Because multiplication is a part of the division process, we will also end up talking about multiplication in this video. So we have these two fractions, these two rational expressions that we want to divide. The first step is to factor everything. So we're going to write factor everything first. For the numerator of the first fraction, notice that x squared is really x times x, and 16 is really a 4 times 4. Since it's a minus, that really means we have a difference of squares. So when you factor the numerator of the first fraction, we're going to have two binomials. Both of them are going to start with x. Both of them are going to end with a 4, and in between you can have one of them being a plus and one of them being a minus. So the numerator of the first fraction, the x squared minus 16, factors to equal x plus 4 times x minus 4. For the bottom of the first fraction, we have a trinomial with 3 terms. To factor a trinomial, we are going to find our special numbers. For this problem, x squared plus 5x plus 4, our two numbers have to multiply to equal the number at the end, the 4, and then add up to equal the number in the middle, the 5. The two numbers that multiply to equal 4 and add up to equal 5 are 1 and 4. Since we have a 1x squared, we can go straight to your binomials, meaning that one of your binomials is going to be x plus 1, using your special number of 1, and the other binomial will be x plus 4, using the special number of 4. Now, we're dividing. I'm not going to worry about changing that into multiplication yet. I'm still trying to just factor everything first. Let's factor the top of the second fraction. Since we again have a trinomial that starts with a 1x squared, you have 1x squared minus 10x plus 24, just go and find those special numbers. In this case, the two numbers have to multiply to equal 24, and the two numbers have to add up to equal the number in the middle, the negative 10. These numbers are going to be a negative 6 and a negative 4. So we factor this to equal x minus 6 times the quantity of x minus 4. Now, last but not least, we need to factor the denominator of the second fraction. Again, it's a trinomial with a 1x squared as your first term. You want to find two numbers that multiply that equal the number at the end, which is a negative 8. The same two numbers have to equal the number in the middle, the negative 7. When you add them, those two numbers are going to be a negative 8 and a positive 1. Since it's a 1x squared, again, we can go straight to your binomials. If it was not a 1 in front, we would have to use the grouping method, but it is a 1, so that makes it a little bit easier. The binomials in this case are going to be the binomial x minus 8, which is multiplied to the binomial x plus 1. Now we have a division problem. Whenever you have a division problem, you want to change division into multiplication and then flip the second fraction. So the first fraction with a numerator of x plus 4 times x minus 4 and a denominator of x plus 1 times x plus 4 is going to stay the same. The second fraction, we flip it, and your new numerator is going to be the binomial x minus 8 times the binomial x plus 1. And the denominator is going to be the binomial x minus 6 times the binomial x minus 4. We've really done probably 90% of the work at this point, because now we're multiplying. We're going to look at the tops of all the fractions and figure out what factors are common on the top and on the bottom. So on the top, just looking at all the fractions together, we have an x plus 4, an x minus 4, an x minus 8, and an x plus 1. In the bottom, we have an x plus 1, an x plus 4, an x minus 6, and an x minus 4. What is the same that's on the top somewhere and on the bottom somewhere? Well, we have an x plus 4 on the top and the bottom of the first fraction. Those cancel. We also have an x minus 4 on the top of the first fraction that cancels with the bottom x minus 4 in the second fraction. You can cancel in different fractions as long as you're multiplying. If it was not a multiplication, we couldn't cancel from different fractions, but since it's multiplication, we can. What else? Well, the first fraction has an x plus 1 in its denominator in the bottom. Second fraction has an x plus 1 in its numerator on top. Those x plus 1s cancel. And all we're left with is an x minus 8 in the numerator and an x minus 6 in the denominator. That is your final answer. Be careful, you cannot cancel those x's because those x's are terms, not factors. A factor means it's multiplied to everything else. And a multiplication would cancel out with a division. But this is a term. It's being, as negative 8, subtracted from it. A division and a subtraction do not cancel out. You cannot cancel those x's. Same thing, we cannot reduce this 8 and this 6 because they are terms, not factors. I hope you learned something. If you have any questions, please let me know. Thank you for watching.